handler for our permissions. So let's go back to the infrastructure project, and inside of my authorization folder, I'm going to add my custom authorization handler. Let's add a new class inside of this folder that I will call the permission authorization handler. This can be an internal and sealed class, and it's going to implement the authorization handler base class. This class expects a generic argument that has to be a type implementing the iAuthorization requirement interface. This is just a marker interface that allows us to specify our custom requirements. So I'm going to create a new class that I will call the permission requirement. It's going to accept a permission value and assign it to the respective property. You can also see that it's implementing the iAuthorization requirement interface. Let's go ahead and move this into its own file, and let's focus on the permission authorization handler. So now that I have my requirement, I can specify it here, and let's implement the missing members of this class, which is the handle requirement async method. Inside of this method, we have to figure out if the current user is authenticated with our API and if they have the required set of permissions. So let's start by solving the authenticated part. I can say if context user and then identity, and I can say if this is not an object where the isAuthenticated value is true, then I can just return from this method. Basically, if the user is not authenticated, we won't even check for permissions. Then I'm going to use my authorization service to obtain the permissions for the current user and then check if they satisfy the permission requirement. So we have to start by injecting an iServiceProvider interface. We have to use this approach because I'm going to register the authorization handler as a transient service. So I'm going to create my custom service scope by saying service provider create scope. Then I'm going to resolve the authorization service using this scope. So we're going to say scope service provider get required service, and let's inject the authorization service. Then we're going to use the tried and true approach of first obtaining the identity ID from the authenticated user context. So I can say context user get identity ID. This is an extension method that I already have, and it's going to give me the name identifier claim. Then I want to get the set of permissions for this user by calling the authorization service. And let's say that I call a method called get permissions for user async. We're going to pass the identity ID to this method, and of course you can see that this method doesn't exist because we haven't created it, but it's going to return a hash set of string type which will represent our permissions. When we obtain our permissions, we can say if permissions contains, and then I can access my permission requirement instance and specify the permission argument. So if this evaluates to true, I'm going to succeed the authorization for this requirement. Otherwise, we're going to exit this method and authorization will fail. And all that's left to do is to implement the get permissions for user async method. So let's create it on our authorization service. We already defined the return type and the argument, so let's solve the implementation. So first, I'm going to fetch the permissions by saying database context set user. Then we're going to filter the user using the identity ID column, and we're going to match this to the identity ID argument. And then I'm going to say select many. And what I'm going to do is select the user's roles, and then we're going to use the role to select the role permissions. So I can say role permissions. This is going to flatten everything into a collection of permissions. Now I want to convert this into a hash set by creating a permissions set variable, and I'm going to use my permissions to project the name of this permission, and we're going to materialize this into a hash set instance, which will get rid of any duplicate values. And now I can just return this value from my method. If we try our authorization solution with the current implementation, we're going to run into one slight problem, and that problem is that we did not register our authorization policies, which are going to be our permissions with the runtime. Ideally, I want to be able to do this dynamically, and we actually can do this by creating a custom authorization policy provider. We're going to base our implementation on the default authorization policy provider, and we're going to implement the missing members, which is a constructor passing in the authorization options. I'm going to capture this into a private and read-only field, and let's grab this value from our options instance. Now what I can do is override the getPolicyAsync method and provide my custom policy based on the permission. So here's what we're going to do. We will call the base implementation of the getPolicyAsync method and see if we get back a value. If the policy that we get back is not null, we're going to return it from this method. So I'll say if policy is not null, then just return the policy value. Otherwise, we need to create a new permission policy instance. I'm going to create a new authorization policy builder. We're going to add a requirement to this builder, and I'm going to give it a new value of the permission requirement policy. Let's pass in the policy name as our permission, and then we're just going to build our authorization policy. We also don't want to forget to cache our policy value, which is why I use the authorization options instance, because I can now say add policy and specify a policy with our name. So we specify the policy name and the permission policy value, and finally I can return the permission policy value from my getPolicyAsync method. Lastly, we want to register these services with dependency injection. So I'm going to navigate to the add authorization method and register our services. So the permission authorization handler will be registered as the iAuthorization handler interface, and the permission authorization policy provider will be registered as the iAuthorization policy provider interface. And now let's test our implementation. Let's send a GET request to the endpoint that's going to return the current user's information. And you can see that we first hit a breakpoint inside of our permission authorization policy provider. The policy that we are looking for is called users read, which also matches the permission that we added on our endpoint. So we're going to call the base getPolicyAsync method, which will return null because we don't have our policy instance. So we're going to create it and also add it to the authorization options object. Then I'm going to press continue, and you'll see that we land inside of our authorization handler for our custom permission. And let's step through and see what's going to happen. So first we're going to verify that the user is authenticated. Then we're going to use the authorization service to obtain the permissions for the currently authenticated user. And you will see that this contains one permission, and this permission is indeed the one that we are trying to satisfy the requirement for. So we're going to call succeed on the authorization handler context and return from this method. So I'm going to hit continue, and we get the result back in Postman. If I send this request again, we're going to land inside of the permission authorization policy provider, but this time when we call the getPolicyAsync method, we will get back a policy instance and we won't have to recreate it. And then we're going to go through the same flow in the handle requirement method and return the response from our API. The disadvantage with this approach to implement permission-based authorization is that we have to query the database every time to obtain the set of permissions for the currently authenticated user. Now you can greatly improve this by introducing caching in the authorization service, and we are going to do this in one of the next chapters. But for now, I'm going to leave the implementation like this, and I'm sharing this remark with you so that you are aware of the disadvantages of this approach. The same applies in our custom claims transformation class, which we added when we were implementing role-based authorization, and here we also have a database query to obtain the user's roles. We could also add caching here to significantly improve the performance and not have to pay the overhead of querying the database on every authorization request.